this question we are given two graphs. We are given y is equal to modulus of x plus 3 minus 4 and y is equal to 3 to the power x plus 3, and we are required to calculate at how many points do both of these curves intersect. If you are looking at the curve y is equal to 3 to the power x plus 3, let us first consider the curve y is equal to 3 to the power x. How does this curve look like? When x is equal to 0, the value of y is equal to 1. As x increases, the value of y also increases, but it increases exponentially. So if you are drawing this as the y-axis, and if you are assuming this as the x-axis, when x is equal to 0, the value of y is 1, but as x increases, the value of y increases exponentially. This is how the curve y is equal to 3 to the power x looks like from the right hand side of the x-axis. But if x is decreasing, if x is becoming lesser and lesser, if say x is equal to minus 10, then the value of y becomes equal to 3 to the power minus 10, which is very low, close to 0, but it is not actually equal to 0. Similarly, if x becomes equal to minus 100, the value of y becomes equal to 3 to the power minus 100, which is again very low, but it is still greater than 0. So as x becomes lesser and lesser, the value of y becomes closer and closer to 0. This is how the curve y is equal to 3 to the power x looks like. So how does the curve y is equal to 3 to the power x plus 3 look like? It will be bumped up above the x-axis by 3 units. So it will look something like this. Let us clear everything up. This is the y-axis and this is the x-axis. Instead of intersecting the y-axis at y is equal to 1 when x is equal to 0, the curve y is equal to 3 to the power x plus 3 now intersects the y-axis when x is equal to 0 at y is equal to 4. So it will intersect somewhere over here, and it will again continue to increase exponentially. But now as x becomes lesser and lesser, instead of touching the x-axis, it will be approaching the line y is equal to 3. So it will look something like this. This point over here is 0, 4 and this point over here is 0, 3. This is the curve y is equal to 3 to the power x plus 3. How does the curve y is equal to modulus of x plus 3 minus 4 look like? Let us first draw the curve y is equal to modulus of x. So this is the y-axis and this is the x-axis. The curve y is equal to modulus of x will look something like this. It will have a V shape and it will be symmetrical about the point which is 0, 0, or it will be symmetrical around the y-axis. Now how does the curve, this is y is equal to modulus of x. Now how does the curve y is equal to modulus of x plus 3 look like? It will be very similar to the curve y is equal to modulus of x, but it will be shifted around the point minus 3, 0. So it will look something like this. It will be shifted 3 units to the left. Initially, the bottom occurs when x is equal to 0 and y is equal to 0. Now the bottom is going to occur when x is equal to minus 3, then y is equal to 0. This is the curve y is equal to modulus of x plus 3. So how does the curve y is equal to modulus of 3 minus 4 look like? Now you have to bring the curve down by 4 units. So it will look something like this. The bottom again occurs when x is equal to minus 3. So it will look something like this. This is the curve y is equal to modulus of x plus 3 minus 4. Now if you are putting a modulus on top of it, if you are taking another modulus, this curve cannot go below the x-axis. So now at this point it is going to come up the x-axis and it will again go down. If you are drawing it more precisely, it will look something like this. Let us clear everything up and let us draw the graph with correct dimensions and to scale, because drawing the graph as accurately as we can is very important, because we are trying to figure out how many points of intersection are there for the two curves. If it is just one curve and if you are just trying to get a sense of the shape, that is one thing. But if you are trying to understand how two curves intersect, drawing both of them quite accurately is very important. It need not be 100% to scale, but at least one of them should not be to scale and the other should not be out of scale. So now again, if you are drawing y-axis and x-axis, as we have discussed earlier, the curve y is equal to modulus of x plus 3 minus 4. What will happen when x is equal to 0? When x is equal to 0, the value of y is equal to 3 minus 4, which is equal to minus 1. What will happen when x is equal to 1? The value of y will be equal to 1 plus 3, that is 4, minus 4, which is equal to 0. Similarly, another point that you can look at is what will happen when x is equal to minus 3. When x is equal to minus 3, modulus of x plus 3 will become equal to 0, and the value of 0 minus 4 is minus 4. This is where the curve is going to get a bottom. Similarly, what will happen when, say, y is equal to minus 7? When y is equal to minus 7, minus 7 plus 3 is minus 4. Modulus of that is 4. 4 minus 4 is again equal to 0. As we have discussed earlier, the curve will be still symmetrical around the point minus 3 when x is equal to minus 3. But now it is going to come below the x-axis by 4 units. So it is going to look something like this. It will be something like this because when x is equal to 0, as we have seen, y is negative. So it will be 0, minus 1. And when x is equal to 1, y is equal to 0. So this is equal to 1, 0. And the bottom happens when x is equal to minus 3. So over here, when x is equal to minus 3, is when the curve is at its lowest point. This is minus 3, minus 4. Similarly, by symmetry, when x is equal to minus 7, y is equal to 0. So this is minus 7, 0. This is the curve y is equal to modulus of x plus 3 minus 4. But what we are looking for is another modulus. We are looking for the curve y is equal to modulus of this. So instead of going below the x-axis, it will continue to come above the x-axis. So it will be symmetrical like this, and it is going to again go back over here. So it will be in the shape of some sort of a W. Now if you are looking at it, the important points are minus 7, 0, which will be somewhere over here. Another point of interest is minus 3, which is over here. And another point of interest is 1. That is over here. Now if you are drawing the curve, it will look something like this. It will come like this. Then at x is equal to minus 3, it is going to reach 4. It will go over here. Then again, it is going to go back to 0 when x is equal to 1. And again, it will come back up. So it will be something like this. This is how the curve y is equal to modulus of x plus 3 minus 4 looks like. You can see that there will be one point of intersection over here that will lie between minus 3 and 1. There will be another point of intersection over here. The second point of intersection will be between minus 3 and minus 7, that is the value of x. And there will be a third point of intersection that will be less than minus 7, the x coordinate. So the number of points of intersection will be equal to 3.